Okay, so today's topic is going to be on implicit differentiation. What is implicit differentiation? So, implicit differentiation, as opposed to explicit differentiation, is instead of having something that is in the form of y equals so-and-so, then just strictly taking the derivative of that to find the derivative of y with respect to x, or whatever that variable is going to be. What's going to happen is that with implicit differentiation is that you have a combination of x's and y's and whatever kind of variables you have in here, and what's going to happen is that you're going to you're going to take the entire derivative of this whole equation and then solve implicitly itself for that derivative of y or x or whatever it is with respect to whatever variable you're looking for. In this case, what we're going to do is we're going to take it with respect to x, but this is just an example for the meantime, trying to explain some concepts here. So, so what we want to do is, in this case, we're going to try and find dy dx by implicit differentiation. And the equation they're going to do to use so is going to be this right here. Okay, so what we're going to do is, since we're finding the derivative of y with respect to x, this tells us that we want to take the derivative of this whole equation with respect to x. So, both sides, take the derivative with respect to x of x cubed plus y cubed equals the derivative of respect to x of 1. Oh, it's pretty messy, just 1 sec. Okay, so then what we do is that you literally just take the derivative. So as before, we can split them up in our basic rules, where you just multiply through. It's kind of like multiplying through. Take the derivative of each piece, so we have that there, and we have the derivative of 1. And as all of you know, the derivative of any constant is 0, so that's going to equal 0. And then if we're taking the derivative of this, we're going to use our power rule. That's going to come down in front, minus 1. It's going to come down in front, minus 1. So you're going to have 3x squared. But remember our chain rule. So in this instance, you always have, remember you have your inside argument here. So you're going to have dx over dx. This is going to equal 1. But for the next part, you're going to have 3y squared times dy dx. This whole thing's equal to 0. And that there is the dy dx that we're going to solve for. So it's as simple as that. You're left with 3y squared dy dx, and you take this whole piece here over to the other side, leaves you with minus 3x squared. Solving for dy dx is going to give you minus 3x squared over 3y squared, and this is what you're left with.